Hello students, welcome to Tutitude. So recently completed Assistant Engineer Tsspdcl Telangana State. Okay, so this question paper we will see. Okay, so we will be uploading all the exam. Okay, so questions and with the discussions. Okay, so with the explanations only we will be explaining all the questions. Okay, so just see these questions will be useful for your NPDCL exam, upcoming GenCo and Transco exam, and all the PSU exams also. Okay, so some of the questions will be useful for your SSC JE and some of the IES also. Okay, so let's see the questions first. A two-port network is defined by the following pair of equations: I1 equal to 2V1 plus V2 and I2 equal to V1 plus V2. The impedance parameters Z11, Z12, Z21, Z22 are given by. Okay, so they have given the equations and they are asking some parameters. Directly it is a question from the two-port network. Okay, so two-port network, direct question it is. You see what we have to do here. So whatever equations they have given, immediately we need to observe what are those equations. See, currents equal to current I1, current I2 is equal to they have given in terms of voltages. So directly they have the equations are like this. Okay, so I1, I2 equal to, so we have the matrix and here we have V1 and V2. V1 here what you will get 2 1 and here it is 1 and 1. Okay, so what is this matrix? Okay, so whatever this matrix, this matrix is nothing but in terms of currents is equals to some voltage they have given. So this matrix is nothing but admittance matrix Y. Okay, admittance matrix Y they have given. This is Y11, this is Y12, this is Y21, this is Y22. Okay, now what they are asking? They are asking impedance parameters Z equal to Y inverse directly. Z equal to y inverse. Okay, so whatever inverse 2 1 1 2, what is the inverse means? 1 by AD minus BC, 1 by AD minus BC, that means 2 minus 1 is 1 by 1 only. So directly I am writing 1 by 1 here into D minus B minus C A. Okay, so D means 1, minus B means minus 1, minus C A value is 1. So this is the answer for us. So impedance parameters are nothing but 1 minus 1 minus 1 2. This is the answer. Okay, so where it is? Option C is the correct one. Okay, for this question. Okay, so whatever set I have taken, this is set A. Okay, so let's see, this question will be different number. Okay, so in some other set. Okay, that's why see the question, two port network question where they are asking impedance parameters. Option is C, 1 minus 1 minus 1 2. That is the answer for that question. Okay, and the next question we'll see. A three-phase star-connected supply of phase voltage of 100 volts 50 Hz is supplying a three-phase star-connected resistive load of 5 ohms per phase. Find the total active power supplied by the load. Total active power they have mentioned. Okay, so only active power they need. Okay, so what they have mentioned, the voltage whatever they have given, that is a phase voltage. That means this is first phase. Okay, so let's write down here. Okay, so first phase, second phase and third phase they have mentioned. So this phase voltage is nothing but so 100 volts 50 Hz, that is AC only. Only phase voltage they have mentioned. Okay, and what is the resistance in each and every phase? A three-phase connected load it is. So connected resistive load of 5 ohms per phase they have given. So this is 5 ohms. So what is the phase current? 100 divided by 5. So that is 20 amperes. Okay, so 20 amperes will be the phase current and 100 volts will be the phase voltage. Okay, so now what is the complete power? 3-phase power we need is the 2 active power we need. Okay, so that means 3 into V phase into I phase into cos phi. So generally cos phi also we have to give, which is power factor, but here it is resistive load, right? Completely resistive load. So what is cos phi? Phi equal to 0, so cos phi is equals to 1. Okay, so directly 3 into V phase into I phase. Okay, so 3 into what is the phase voltage? 100. Okay, so next what is the current? Phase current, that is 20. Okay, so you will get 6000. Okay, 6000 watts you will get. Okay, that's the answer. Okay, so similarly we can find out reactive power also, you can find out complete power, but this is resistive load, right? What is the reactive power? 0 directly, no need to check anything. Okay, if they want to confuse a little bit, okay, they want to waste your time, then they will ask about reactive power also. Okay, so answer for this question is A. Okay, 6000 watts. Okay, and the next question is, okay, So the voltage phasor of a circuit is 10 at an angle of 15 volt and the current phasor is 2 at an angle of minus 45 amperes. The active and the reactive powers in the circuit are, okay, they are asking both active power and reactive power for the given circuit voltage and current. Okay, this is voltage and current is nothing but 2 at an angle of minus 45. Okay, so whenever this model of question comes, okay, so in terms of angles, okay, so no need to calculate anything, directly we have to do. Okay, so what is the complete power? Apparent power S equal to V into I. Apparent power is this one. Okay, so what is apparent power? 10 at an angle of 15 into 2 at an angle of 45. What it is? Let's calculate. It is V is nothing but 10. Okay, so 10 into 2 is nothing but 20. 20 at an angle of, okay, so 20 at an angle of, so what is the angle difference between voltage and current? So that will be equal to 15 and 45. Okay, so minus 45. Some students will used to get doubt. Okay, how it is. For that you need to follow like this. Okay, if you have doubt, you have to follow like this. Okay, so 2 at 20, what is this voltage? 10 at an angle of 15. Okay, so this is the angle 15. For example, this is 0, this is 15 degree. Okay, so this is 15 degree and this is at minus 45. Okay, so 2 at an angle of minus 45. So this is minus 45. Okay, so minus 45 plus 15. What is the angle difference between these two? That will be 60 degree. Okay, so angle difference between voltage and current is nothing but that is 60 degree now. Okay, so angle difference total is 20 at an angle of 60 it is. So directly we can do. Okay, so this is the apparent power means. So what is the active power? Active power P is equals to VI cos phi. Magnitudes we have to take V into I. So what is V? Already V into I we have already, that is 20. 20 cos phi. 20 cos phi is nothing but 1 by 2. Okay, so cos 60 is nothing but 1 by 2. So active power you will get 20. Okay, so active power you will get 20 divided by 2, that is 10 watts. Okay, 10 watts, and only one option is there, active power and reactive power they are asking. Directly we can solve this. Okay, and if you want reactive power also, what you will get? Q reactive power equal to, so 20 at an angle of, okay, sin phi. Okay, 20 sin phi you will get 20 into sin 60. Sin 60 is nothing but root 3 divided by 2. So 20 into root 3 divided by 2 you will get 10 root 3. 10 root 3 is nothing but, so root 3 value is nothing but 1.734. So if you multiply you will get 17.32. Okay, so like this. Okay, so option A is the correct one for this. Okay, two coils having equal resistance but different inductances are connected in series. The time constant of the series combination is, okay, so they are asking time constant of series combination. Okay, so whenever one coil is there, what is the time constant of that coil? It will be having some inductance and resistance they have given. So time constant is equals to L divided by R. Okay, so L1 divided by R. Similarly, for the second coil also there will be time constants, that will be, so L2 divided by R it will be. Okay, so time constant of second coil is equals to, okay, now what they are asking, they both are connected in series. Okay, so whenever they both are connected in series like this, what will happen? Total inductance will become L1 plus L2, total resistance will become, so actually equal resistance they have mentioned. Okay, so equal resistance, so it will be like R plus R. Okay, so it will be total resistance of 2R it will be. So now what is the complete time constant means? L divided by R. Okay, so L1 plus L2 divided by 2R it will be. Okay, so this is the complete time constant. Okay, so what they are asking, how it is the time constant of a complete coil they are asking. Okay, so we can write down as L1 by R, L1 by R. Okay, so L1 by R plus L2 by R divided by 2 we can write down. So directly we can get, this is the time constant of first coil, this is the time constant of second coil. Okay, so T1 and T2. Okay, so we can write down as T1 plus T2 divided by 2 it is. Okay, just see the options. Sum of time constant of individual coils. Okay, this is like a time constant 1 plus time constant 2. Wrong. Okay, this is wrong. So average of the time constant of individual coils, that means T1 plus T2 divided by 2. This is the correct one. Okay, geometric mean of the time constant. Geometric mean means under root time constant of one, time constant of second one. Okay, product of time constant T1 T2. So now we have got the answer T1 T2 divided by 2. That is the answer. Okay, next question. The sinusoidal waveform of a current is given in following figure. represent the current in the form of equation. Okay, so they have given the current waveform, we have to represent in terms of equation. Okay, so this model of questions, so generally if you don't follow any of the procedures and all, so definitely you will get within the seconds. Okay, if you check in particular procedure, then definitely you will take more time. Okay, that's why I'm coming with the options. Okay, directly you see what is the maximum value of this one, 18. Okay, so directly we can eliminate one option. Okay, I'm just eliminating this option because maximum value is 9. Okay, so let's eliminate that. And you see normal sinusoidal waveform is like this. Normal sinusoidal waveform is like this. Now what they have did, so that the whatever waveform it is, okay, so whatever waveform it is starting, okay, it is starting from here. Generally you may think like this. Okay, the same sinusoidal waveform is starting from here like this. So that means it is shifted this much. It is shifted this much. That's how you got the negative side. Okay, so negative side first here. Okay, that means from here it is getting started. Understood, right? If this waveform is starting, okay, if this waveform, so that means normal sinusoidal waveform only. So if it is starting from here, then you got the, so this waveform. Understanding, right? So that means you observe, okay, so up to here it is, okay, so up to, so where it is, so we have to transfer, we have to shift this one up to here. Okay, so that means if you take the complete waveform, okay, so how much we have shifted means we have shifted more than 90 degree directly. Okay, just observe from here. Okay, so no need to check any of the parameters, directly how much we have shifted, we have to observe that. Okay, if this is the sinusoidal, the waveform is starting from here means we have shifted this much. What is this angle? So more than 90 degrees. Sinusoidal waveform is shifted more than 90 degree. That's it. Okay, so you got the answer directly. So sinusoidal waveform which is having a maximum magnitude of 18 is shifted more than 90 degree. That's it. That is the answer. Okay, so option D is the correct one for this. Okay, so some people may again they will check. Okay, so maybe cos it may be like this. Okay, so anyhow if it is a cos, directly we have to start. Okay, so we have to start the cosine waveform like from here. Okay, so let's see, you can think in the same way. Okay, for the cosine also we have to think in the same way. Okay, so like cosine waveform generally starts from here, so maximum value to 0 value, next this one, next this one. Okay, to get this waveform how much shift we have to do? So from here, that means if we have to represent as a cosine waveform, this has to shift less than 90. Okay, but here 150 is there, so it is definitely wrong. Okay, it is not at all possible with 150 degree shift using cosine waveform. Okay, so answer for this question is sinusoidal signal which is shifted more than so that more than 90 degree. That is the answer for this question. Okay, that is the option D. And the next question is, a phasor is rotating with angular velocity of 628 radians per second. Determine the frequency of the phasor and its time period. Okay, so they have given angular velocity. Okay, that means omega they have given as 628 radians per second they have given. Okay, so generally how we can represent this one, 2 pi f is equals to 628. Okay, so that's what they have mentioned generally. So we might have noticed something. Okay, for a 50 hertz frequency. Okay, so we used to practice the questions, right? Okay, so while practicing we will see something. Okay, so 314 radians per second. Okay, so what is this 314 radians per second? For the 50 hertz you will get this one. Okay, for the 50 hertz you will be getting, so this one. Okay, so 314 radians. Otherwise you can just substitute. Okay, so what is the value of pi? You can substitute 22/7 and you can get the answer. There is no problem. Okay, so anyway 628 they have mentioned, that means 314 means 50 hertz and we are getting 314 double. Okay, so 628 means 314 2 times, that means frequency is now not 50 hertz, it is 100 hertz directly. Okay, so that means the frequency is 100 hertz and we have only one option. Okay, so when frequency equal to 100 hertz, what is the time period? Time period is equal to 1 by 100 hertz. Okay, so that means anyway for the 50 hertz frequency, so generally we used to practice all the questions. Okay, any subject we used to practice with 50 hertz because our frequency is 50 hertz only. So that's why for this also time period, what is the time period of this one? That is 20 milliseconds. When frequency increases or frequency doubles, time period half. That means 10 milliseconds will be the time period. That is direct question, within seconds we have to answer this. Okay, so next question we will see. A series RLC circuit is connected across a single phase AC voltage source. The voltages measured across R, L and C are 20 volt, 40 volt and 55 volt respectively, and an ammeter measures the supply current as 3 amperes. What is the power factor of the circuit? Okay, so they are asking power factor, and directly we have to understand some things. Okay, you see capacitor voltage is greater than inductor voltage. Okay, so capacitance voltage is 55 volt, inductor voltage is 40 volts only, so directly it is a lead circuit. Okay, so voltage across the capacitor is more, means capacitive reactance is more compared to inductive reactance. Okay, so that means when you can directly give the phasor diagram. Okay, so whenever it is a series RLC circuit, I am taking current as a reference. Okay, because in series circuit current is the same thing in all the elements. Okay, that's why current we are taking as a reference. Okay, and resistance voltage they have mentioned, and in resistance current is in phase with voltage, so directly, so this is 20 volt they have mentioned. Okay, so this is 20 volt. Now inductor voltage means in inductor voltage will come first. Okay, so voltage will come first, and in capacitor voltage will be in leading. Okay, so compared to inductor. Okay, so that otherwise we can understand like this. Okay, so in inductor current lags. Okay, current lags, in capacitor voltage lags. Okay, so like this we can understand. Okay, so in inductor current lags, in capacitor voltage lags. Okay, so we have to understand like that. Okay, first we will see the inductor current. Okay, so what is inductor voltage? That is 40 volt. Okay, so 40 volts we have to represent first. Okay, so voltage has to be in lead when compared to current in the inductor, otherwise current will be lagging when compared to voltage. The magnitude they have mentioned, that is 40 volts. Okay, so I am representing up to 40 volts. This is 40 volts. Now capacitor voltage is nothing but 55 volts, so magnitude you have to take little bit more, so that's why it is 55 volt. Okay, so 55 volt. So now anyway these two are opposite, right? I will take the equivalent. So 40 is this one, 55 is this one, so you will get around 15 is this one, remaining 15. Okay, 15 volts is this. Okay, now if you join these two, so directly, otherwise whenever you are calculating a complete voltage, generally we used to take like this, extend these two, and wherever you got like this, that is nothing but, so angle we will be getting. Okay, so let's say this is the angle, complete angle. Okay, so this is the complete voltage or source voltage we can consider, and we can observe something. Okay, so current is going first and voltage is coming next, means it is a lead circuit. Okay, so because capacitor voltage is more, directly we can give this point also. Okay, so what is this angle? So that angle only, so we have to consider, we have to calculate the power factor. Otherwise directly power factor is nothing but, so if this is phi, cos phi is the power factor. What is cos phi? Cos phi is nothing but adjacent divided by, so hypotenuse you will get. Adjacent value is nothing but 20 divided by hypotenuse value. What is the hypotenuse value? 20 square plus what is this, 15 square. Okay, so 20 square plus 15 square, 20 square is 400 plus 15 square is 225 under root. Okay, so you will get 20 divided by cos phi, which is nothing but power factor. Power factor is 20 divided by, so under root 625 is 25. Okay, so 25, so you will get so 4 divided by 5, so which is 0.8. Already we know it is current leads the voltage, means it is a leading circuit, or directly we can give option D is the correct one. Okay, and the next question is, a balanced 3-phase star connected voltage source has a phase sequence of ABC. If voltage of phase A to the neutral is 10 at an angle of 0 volts, the line voltage VBC with respect to the phase A is given by. Okay, so they have mentioned, so it is a balanced 3-phase star connected load. Okay, they have given it is a balanced one. Okay, that means we have the phase sequence also. They have mentioned only one thing first, that is 10 at an angle of 0. A phase voltage they have given, that is 10 at an angle of 0. Okay, so let's represent 10 at an angle of 0. I am representing as a normal coordinate system. Okay, this is 0 degree, this is 90 degree, this is 180 degree, and this is nothing but 270 degree, and again 360. Based on this only I am just drawing. Okay, so that's why 10 at an angle of 0 I am mentioning here. So this is VA. Okay, so next after 120 degree they have given the phase sequence as A B C, right? That means first A, after that B, after that C. Okay, so I'm considering VA is nothing but 10 at an angle of 0 means VB is nothing but 10 at an angle of minus 120 degree, and VC is nothing but 10 at an angle of minus 240 degree. Okay, so minus 120 degree we have to represent 90 plus 30 minus 120, this is VB, and the other one is nothing but VC. Okay, so all are having equal magnitudes. 120 degree shift will be there between all the three. Okay, now what they have given, we have to calculate the angle. First we will calculate the angle. Okay, so with respect to A phase we need voltage, line voltage of VBC. VBC we want, but VBC we don't have, so what we have to do, VB minus VC we have to calculate. Okay, VB minus VC means, so VB plus minus VC. Okay, so where is my this is VC and this is nothing but minus VC. Okay, so now we have to add these two, VB and minus VC we have to add. So to add, so according to the theorem we have to extend these two, so then wherever these two touches, that is nothing but our VBC vector. Okay, so now we have to calculate the angle difference between these two. Okay, so now you see what is the angle. VA is this one. To get the VBC, how much we have to travel? Minus 90 we have to travel. Okay, so that too magnitude is not 10. Okay, so this is the phase voltage and this is the line voltage. If you have calculated normal, okay, so in every subject we used to calculate, right? Okay, so line voltage will be √3 times of phase voltages when it is a star connected system. Okay, so anyway 10 √3 magnitude you will get, and you will get a shift of minus 90. Okay, so what they have given, the line voltage VBC with respect to the phases A is given by. Okay, so if you have to get VBC, how much shift we have to do this VA, we have to shift minus 90 we have to do. Okay, so that is the answer for this question. Okay, so anyway even this angle also we can calculate. Okay, you see one thing, this is 120, this is 120, this complete one is 120. Whenever you are drawing again as opposite to this one means, so from here to here it is 60, so from here to here also it is 60 only. So and again these two having same magnitude, whenever you just calculate the equivalent of these two, you will get the exactly 30 degree and 30 degree. So total 30 plus 60 is nothing but 90 degree you will get. Okay, so anyway no need to consider all these things in the exam, directly we can answer this is 90 degree. Okay, so from here to here you will get minus 90 total angle. Okay, so answer for this question is 10 √3 at the angle of minus 90 degree volts. Okay, the next question is the Thevenin's equivalent voltage VTH in the following circuit is. Okay, so they have given circuit and they are asking what is the voltage across these two terminals. Okay, so we have to minimize the solution time. Okay, that's why, so we have to choose the best method to solve this type of problems. Okay, any circuit models they are giving means you can apply any method, like nodal analysis you can apply, mesh analysis you can apply, like different methods we can apply. Okay, so but whatever method which will give in very less time. Okay, so that only we have to do in the exam. Okay, how we will be knowing that means with practice only you will get all that. Okay, so anyway just see, we need voltage across this one. So what is my idea, so I will convert this voltage source in series with resistance into a current source in parallel with same resistance of 3 ohms. Okay, so then you will get the circuit like this. Okay, so whatever current source you will get here, that is nothing but 10/3 amperes, and already one more current source in series with this one it is there. Okay, so that is 3 ohms in series with 12 amperes it is. Okay, and whatever this 3 ohms will be coming here. Okay, so this is 3 ohms, and here all are connected in parallel, and whatever 8 ohms is there here, so anyway no current will flow because that is a open circuit. Okay, we want voltage between these two terminals. Okay, just see 12 amperes is coming like this, so whatever this 3 ohms is there. Okay, so there is no current will no drop will be occurring, whatever 3 ohms will be there. Okay, so that will not change the current in this element. Okay, that means 12 amperes will be coming, and here 10/3 amperes is coming, so total current will be flowing in this. Okay, so what is the current in this one, so current I is nothing but 10/3 plus 12. Okay, so that is nothing but 36 plus 10, 46 divided by 3. That is the current in this element, 3 ohms resistance. Now we want voltage VTH means between these two terminals only we want. So that means between these two terminals only we want. Voltage is nothing but 46 divided by 3 into 3. Current into resistance. So you will get 46 volts. Okay, like this. So these are all the questions from the circuit subject, okay? So and anyway, in the different video, we will see the questions about all the subjects, okay? So all our team will be explaining, all are experienced and all are from the NITs or IITs background only. So we will give all the solutions for this assistant engineer exam, okay? So these questions will be useful for your upcoming exams also, okay? So please practice again these questions, okay? This will be useful for you. Thank you so much.